he discovered something about right angled triangles. So the objectives, we're going to start with objective 1, which is Pythagoras' theorem. The second half of the lesson, which is the other lesson in its own right, is we're going to look at measures. We're going to talk about the various measures we use, converting between measures, getting a concept of measures and estimates, and this thing called compound measures. Anybody know what a compound measure is? Anyone come across them before? It's two measures together. It's things like miles per hour, kilowatt hours, meters per second, stuff like that. So it's where you're combining two units of maybe sort of distance and time, miles per hour. Today's thunk. Right, your smart recap. I've got 3 questions for you. 3 questions that we've done in the past that will be very, very handy today. Who'd like to solve this for me? What would I start with? What's a good starting point for that first one?
Working out what 4 squared is.
So let's rewrite it so we can see what we're dealing with. Everyone happy with that? Look familiar? So now I'm looking for something. Plus 16 is 25. Do algebra if you like. I'm going to solve that using algebra.
Minus 16.
Good. I want a on its own, so take away 16 off both sides. So a is equal to 9. Perfect. And we're going to use that skill quite a lot today. Excellent. Second one, b is equal to the square root of 64. So what's b? 8. Why have we got 8? That's the correct answer. Very good. Tick VG. But why is it 8? How did you know it was 8?
That's what goes into it.
Brilliant. It's because it's the number that multiplied by itself gives you 64. And when we did squares, square roots a good few months ago, told you to remember certain number pairs. Yeah? So you understand 5 goes with 25, square root of 25 is 5, and so on. And this is one of those pairs. So as far as squares are concerned, you should really know the squares and the square roots of numbers 1 to 12. Okay? The last one, rearrange the formula to make b the subject. So a bit of algebra.
C take A equals B.
Good. So how did you do it by steps? How did you move the a across then?
I don't know, I just did it.
That's good. You did it right. That's good. Okay. Algebra-wise, I'm trying to get b on its own, so I need to...
Because it's plus, you need to take it away.
Good. So that's a plus a. So we take away the a here, we take away the a there, and it leaves us with b equals c minus a. And again, you'll be doing something very similar to that when we're solving these triangles, and you'll see how it all fits together, okay? So everything on there is to do with Pythagoras and how we're going to start using Pythagoras to solve things. Just a quick check, for those of you who got some of your homework wrong, some of you keep putting the wrong words in. What is that?
Kite.
Kite? Rhombus? What is it not?
Diamond.
Good. It's not a diamond, it's a rhombus. All the sides are the same, and it's kind of tilted a bit, yeah? I loved some of the homework where I got, it said, oh, draw the 4-sided shape. You've all correctly drawn rhombus. And the number of people that drew a square on its side, like that, that's not a rhombus, that's just a square on its side. You have to tilt the angle so you haven't got 90. So it's kind of like that.
I put rhombus, aka just to wind you up.
I'm glad my wife was not within reading distance of that homework when I marked it.
I've just handed it in.
You can take it back in the break.
Yeah, well.
I'm joking. Right. So this Greek geezer, Pythagoras, this is what tonight's all about. 500-ish BC, he came up with a theorem to do with right angled triangles. So keep that in the back of your mind. You can only use this if you've got a right angled triangle, okay? And we're going to kind of discover what it is. So here's my right angled triangle. Let's talk about the properties of a right angled triangle here. What does it have to have?
3 sides.
3 sides, good. What else does it have to have? A right angle, good. So I've got a right angle and I've got 3 sides. What can I say about this side and this side?
Same length.
Do they have to be the same length?
No.
No. They kind of look the same length in what I've drawn here. They don't have to be, so they're certain lengths. What about this side here?
Longer than those two.
It's the longest side. It's got a special word. Anybody know what the word is in maths?
Oh,
Ooh.
yes.
Yeah, the hippopotamus. A hypotenuse. Okay? The side that is opposite the right angle every time, trust me, every time, is the longest side on a right angle triangle. And it's called the hypotenuse. And this is what This geezer Pythagoras discovered, okay? So on a right angle triangle, you've got to have a right angle, and opposite the right angle, you've got to have your longest side. There is no other way of doing it. You can't draw a right angle triangle with the longest side here or there. They're the two shorter sides, okay? Good. Oh, that looks like. So, on these diagrams, X, Y, Z, which one's the hypotenuse?
Z.
Everyone sees Z is the hypotenuse. This one here, ABC?
B.
B is the hypotenuse. This one here, ABC, which one's the hypotenuse? C. So they're not always going to give you a nice right angle triangle that's stood up on its end. Nasty, nasty people that they are, could put it here. But as long as you recognise the right angle, you can spot the hypotenuse. And that's really important, because in a minute we're going to learn to take the measurements for two of the three, and you need to manipulate them in the correct way. And you always have to be able to spot the hypotenuse to do that. So, I'm not going to get you to draw these because it took about 20 minutes and we probably haven't got 20 minutes. If we go back to last week when we were drawing triangles, if I drew a triangle 3, 4, this side here would be 5. Okay? Let's look at that on this diagram. What I got them to do today, and it took about half an hour to do this, and I really haven't got half an hour, is that when we drew this, and this was 3, and this was 4, when they got their rulers out and measured it, this was 5. And I gave them this table, and I said, populate the table. And what it gets you to do is it multiplies 3 by itself to give 9, 16, and 25. And the point of the exercise is asking them, if I did the same here, this would be 5, 12, and 13. And this would be 6, 8, and 10. And when we got them to square the numbers, there was a relationship between the numbers. Can anyone see what the relationship is on those numbers, the squared numbers?
Those two discover it.
Brilliant. You've just discovered Pythagoras' theorem. Okay? So, when we do that, when you square the first side and the second side and add them together, it's the same as the third side squared. That is Pythagoras' theorem. Okay? So, Fiona said at the start of the lesson, when you square the two smaller sides and add them together, it's the same as squaring this. And the reason it's square is because if you drew a square, which we'll look at visually in a minute, then this 4 by 4 square and this 3 by 3 square is exactly the same as this 5 by 5 square. And I'll show you that visually in a sec. Okay? So let's have a look then, what Pythagoras discovered. So what he said mathematically, so whenever you see a right angle triangle and I say, what does it mean mathematically? It means this, that a squared plus b squared will always equal c squared. In other words, the two smaller sides squared will always equal the hypotenuse squared. And it's important that you recognise the hypotenuse. Okay? So here my two smaller sides are a and b, my hypotenuse is c. And what he said in words was, for any right angled triangle, the sum of the square of the two smaller sides is equal to the square of the larger sides. And it quite literally means that if you drew a square for this side and you drew a square for that side, the areas of the two, when you combine them, would make that side there. Okay? That is Pythagoras' theorem. Okay? And we can use it to work out any combination of one of the three sides. So let's look at the basics then. Pythagoras' theorem. What is Pythagoras' theorem then? So this question is asking us to find the length of x. So what is x with respect to our right angle triangle? It's our hypotenuse. Yeah? X is our hypotenuse. So whenever you get a question on right angle triangles, what's the first thing you're going to write down?
A squared plus b.
And that's just our simple way of saying we know Pythagoras' theorem. What you have to do then is substitute the information into that you're aware of. So in this instance, we're trying to work out what our hypotenuse is. So C is always the hypotenuse. So in this case, it's equal to x squared. We don't know what x is yet. But what do I know about that triangle?
3 and 4.
I know I've got a 3 squared and I've got a 4 squared. Doesn't matter which is A and B, they're just the two smaller sides. So this is telling me this information here. So how do I solve this then? What's the first step we could do quite easily?
3 times 3.
3 times 3 is 9 plus
4 times 4.
16 equals x squared. What can I do next?
Do the sum.
Add these two. 25 is equal to x squared. But I don't want x squared, I want x on its own. So here's an algebra problem for you. What's the opposite of squaring something? Square root. So if I square root my x squared, it just gives me x. It's cancelled each other out. But if I square root this side, what have I got to do?
The other side.
Square root the other side. It's algebra. What I do to one side, I do to the other. What's the square root of 25? 5. So x has a value of 5. So if I know two sides on a triangle, I can calculate the third side using Pythagoras' theorem. Yeah? So what we're going to try first is I'm going to give you... Oh, that's a visual representation of it. So here's your triangle, and it's just saying what we drew earlier. So these areas here added together, the red areas added together, give you the blue area. And here's a visual representation of that. Oh, it didn't work earlier, so I think I've pre-called it up. So this group of students, I think as a project, said, how do you represent Pythagoras' theorem? So they came up with this very visual representation using water. So the two smaller sides as area, when you add them together, create the same area as the hypotenuse. And vice versa. If you've got the hypotenuse and you split it up, it equals the other two sides. It has to. That's what Pythagoras came up with. Yeah? So that's kind of a visual representation of what we're doing. So when we talk about a squared and b squared and c squared, we're actually talking about squares. Yeah? Make sense? Okay. Let's get back on with Pythagoras. So let's try 3 then. Have a go at those 3, A, B and C, and see what you come up with for the hypotenuse. Nuses.
You need to draw it.
No, don't draw it. Calculate it. Okay, the first one then. Who'd like to start me off? What's my starter for 10? What should I do?
Right, A squared plus B squared.
Perfect. Start. A plus B squared equals C squared. That's Pythagoras. So that's our starting point every time with the right angle. Sorry, right angle triangle. So what can I substitute in there? What do I know?
A squared
Yeah.
is 25.
So 5 squared plus
4 squared.
4 squared equals
C squared.
x squared. Got x there. Might as well change it. Yeah. So the two things I know are the two shorter sides. What I don't know is the hypotenuse. So that has to be that. So that's x squared. So that's 25 plus 9 equals x squared.
Why is 4 squared?
Oh, sorry.
I thought it was 16.
Miles away. 16. Okay, which is
41.
41 equals x squared. But I don't want x squared. I want x on its own. So what's the opposite of squaring something? Square rooting it. So I need to square root, and this is the bit everybody forgets. I have to square root that. So that gives me x on its own because I've done the opposite. So what's the square root of 41?
I got 6.4.
6.4. Perfect.
So I didn't think that was right.
I didn't trust it.
I was
I
like-
know.
Happy with what we did there. The step that everybody seems to forget is this one here. Because they get to 41 and they think it equals x. It doesn't equal x, it equals x squared, which is why I get you to write it out in full up here. Okay? So not being clever and writing numbers down or the letter x. If you write this in full, you remember that it's squared and you're looking for x on its own. Okay? Let's do the next one then. Start for 10.
A squared plus B squared
A squared plus b squared.
is C squared.
Brilliant.
That's 8 squared plus 6 squared,
Brilliant.
which makes x squared.
Call it h this time.
Oh, h
It's
squared.
gonna be- that's good. Yeah?
And then
So,
that's 64
yeah,
plus 36.
yeah.
That's 100.
And what's it equal to still?
H squared.
Squared, yeah. So we've got 100 equals h squared. So I don't want h squared.
So we want
h on its own.
Square root of 100.
So the square root of that leaves me with h, and the square root of 100 is
10.
It's all this in the exam. It writes it out like that.
I would suggest you write it out like that so you don't miss anything. Why? What would you not put in?
I'll just go straight to 8 squared.
You just put 64 plus 36 equals h squared.
Or
That's
Would you
Yeah,
want
if you want to.
just say that 64 and 36.
Yeah, if you want to, you can miss a step out of this. I mean, the marks are generally for getting something like this and making sure you get the right answer. Probably 2 or 3 marks for a straightforward question. This is kind of a D-level question that we're dealing with at the moment. You'll see the hard ones in a second, and that's why I tend to write it out in full every time. And the fact it could be on YouTube, so you might want to see how I did every step, okay? So let's have a look. Gone all correct. Next one. Who'd like to start?
A squared plus b squared.
A squared plus b squared
Equals
equals
C
c squared.
5 squared plus 12 squared equals y squared.
Good.
So it's 25 plus 144 equals y squared.
Good.
169 equals y squared. And the square root
So don't forget the square roots.
is 13.
Everyone happy with that? Everyone get that?
Yep.
Good. So that's the basics. That's when we've been given the 2 smaller sides and we have to calculate the hypotenuse. We can use this skill to work out whether a triangle is truly a right angled triangle. To be a right angled triangle, it must adhere to Pythagoras' theorem. So we've got 2 triangles here. So they might both be right angled triangles, they might not. So how do we check which one is the right angled triangle? Well, you do it through Pythagoras. So what did Pythagoras say?
A squared plus b squared equals c squared.
So let's do it then on this one.
So it'd be 5 squared.
Yeah,
25
yeah,
plus 3 squared 9
yeah,
equals 5 point. Oh, it equals c
yeah.
squared.
C,
Yeah.
whatever c squared is. So we've got 26 equals c squared.
36.
Sorry, 36. So to get
Good or
what is wrong with me tonight?
Yeah.
34 is equal to c squared. So how do I get c on its own?
Square root it.
Square root both sides. So c is equal to what? What's the square root of 34?
6 point something.
Is it?
Is it?
Shouldn't be bigger than
5.8.
6 because 6 is to 36.
5.8.
8.
5.8.
What's it?
So that's a right angled triangle. And we've proved it's a right angled triangle because when we've applied Pythagoras, the hypotenuse is 5.8. And yes, it is. So that is a right angled triangle. Let's try it over here then. 7.5 squared plus 4.5 squared is equal to whatever the hypotenuse is. 7.5 squared.
I've got 56.25.
That sounds good. 56.25 plus 4.5 squared. Good practice for square root buttons.
20.25.
20.25. So I've got 76.5 is equal to c squared. So the hypotenuse should be the square root of 76.5. Square root of 76.5.
8.74.
8.74. And they're telling us it's 8. So that cannot be a right angled triangle. So you can use Pythagoras to prove if something is or is not a right angle. To be a right angled triangle, it must adhere to Pythagoras. If it doesn't, then that cannot be a 90-degree angle. They've drawn it to look like one, but it
I
isn't
was
quite.
just going to say that. Based on the calculation.
Yeah, but it looks like it, doesn't it?
Yeah.
And they always say that on the paper, not drawn to scale or whatever. They're trying to throw you, and they're asking you to check it. If they ask you to check which one's the right angle, you do it mathematically. Not you protractor and whatever. Okay, so now we understand what Pythagoras is and does. We can work out one of the 2 smaller sides if we're given the other smaller side and the hypotenuse. Okay, so if I wanted to work out what A was and I knew B and C, you just move things around like algebra. So to get A on its own, what would I have to do with B? Take it away. So you'd end up with A squared equals C squared minus B squared. And then once you get a squared, you square root whatever's over there and you end up with it, okay? So a bit of algebra to move things around to solve the smaller sides. Let's do a couple of examples to show you how this works, okay? So this time, I've got what? I've got one of the smaller sides, because that's my right angle, and I've got one of the smaller sides, but I've also got the hypotenuse. So what did Pythagoras tell us? Okay, that's what he gave us. So what have I got this time?
B and C.
I've got B and C, haven't I? Because I don't know what A is. So I don't know what A is, I can't do anything with that. But I do know B is 12 and C is 13. Can you see what I've done there? So you have to substitute the numbers into the correct part of Pythagoras' theorem. Because we were given the hypotenuse this time, I know what C is. This is one of the smaller sides, so it's one of the smaller sides. Okay. Let's solve that then. So A squared is equal to, sorry, A squared plus 144 equals 169. Bit of algebra, step one. How do I get A on its own? So what's step one towards getting A on its own? What would you do in algebra?
Minus 144.
Brilliant. I'd take away 144 from both sides. So I've got A squared over here is equal to 25. I don't want A squared, I want A. What do I do next?
Square root it.
Square root it. If I square root that, I have to do the same over there. That leaves A on that side, and the square root of 25 is 5. So this missing side down here, obviously not drawn to scale, is 5 centimetres. See how we got that? Yeah? Let's try another one then. Or you have a go at that one for a minute or so. Okay, let's talk through this then. What do I know? Tell me what I know.
A squared plus B squared.
Ah, A squared plus B squared equals C squared. Right angle triangle, Pythagoras, first thing you write down. Next bit.
C squared is 14 squared.
Good. So we know the hypotenuse this time. We can spot it a mile away because it's the one opposite this. So that's 14 squared.
And then the B can be 6 squared.
The B can be 6 squared. Yeah.
And that leaves with A squared.
A squared. It doesn't matter which way round. I know it's giving you B there and all. It's irrelevant what they label this. If you wanted to be really pedantic, you could say, we'll take that as A.
Yeah.
So that's 6 squared plus B squared. It doesn't really matter which way round you do it, okay? You'll still come up with the same answer. So let's do the next stage.
So that's 36 plus B squared.
36 plus B squared equals,
196.
it is 196. So a bit of algebra to solve. Step one of the algebra.
Minus 36.
Everyone see that? We take away 36 from both sides, and it gives me B squared is equal to 160. How do I get B on its own? Because I've got a B squared.
Square root it.
Square root it. Both sides gives me B on its own is
12.6.
12.6. Can we see what we did there? Yeah?
I don't think I know what steps, but I got the right answer.
Woohoo!
They
You must be
don't-
doing something right to get the right
They
answer.
always say to how many decimal points.
Sometimes I would generally do it to one decimal place,
They
especially
don't say.
if they use one decimal place. So
Yeah, right.
in the previous one where they had like
7.5,
7.5,
yeah.
I would give it back to them as one
Yeah.
decimal place.
Mm-hmm.
Okay, last one, have a go. So what's the missing side? I haven't labelled anything this time. No A's, no B's, no C's. Just tell me what that missing side is.
A squared plus B squared equals C squared.
Always a good start with a right angle triangle.
C squared plus B squared equals 25 squared.
Excellent. So that's substitution. We've now put in what we know from our diagram.
9 plus B squared equals 625.
Good, so we've multiplied everything out.
Minus
Yeah. Minus 9 from both sides. So I've just got B squared over here and 616. Final bit.
Square root.
Square root your b to leave b on its own. What you do to one side, you have to do to the other. Square root of 616, 24.8. Perfect. Enough of them and ladders. Okay. Next week, I'm going to get you to do something particularly nasty, which is work out the area of a triangle. In order to work out the area of a triangle, you have to be able to calculate its vertical height. Okay. On an equilateral triangle, an isosceles triangle, where is your vertical height? If I drew you a nice right angle triangle, what's my vertical height of my right angle triangle? This side here, yeah? Where's my vertical height for my two triangles that I've got up on the board? It's down the centre, isn't it? That's my vertical height. That's my vertical height. You now have the skills, having just taught you Pythagoras, to work out those vertical heights. How do I work out the vertical height of this one?
Oh, because it's equilateral. So
It's an equilateral triangle.
You could halve the bottom bit, so you've got
Half the
three.
bottom, so you know
One of
from
them is
there.
three.
Sorry, half the bottom. From there to there is 3 centimetres. What else do I know?
The other side 6 centimetres.
That's 6 centimetres.
So that other side.
So
You
what's
can
this
work
dotted
this-
line?
You can work it out.
How can you work it out?
By doing the same thing.
Because I've got a right angle there,
Yeah.
I've created a right angle triangle. So let's do it. So we've got a squared plus b squared equals c squared.
6
Just
squared.
said, Mandy said, is it 3 squared
3 squared
plus
6 squared.
B squared.
plus
b squared, because the 6 is the hypotenuse. Yeah? That's how you solve it. So now if we multiply it out, we've got 9 plus b squared equals 36. Minus the 9 leaves me with b squared equals 25.
Square root it.
Square root both sides, b is equal to
5.
5. So the height of that triangle is 5. That's going to come in really useful next week. Because to get the area of a triangle, it's half the base times the vertical height. You now know how to calculate vertical heights. It will save some time next week. Righties, start me off. Where should I start?
Your equation, a squared plus b squared equals c squared.
Good, always a good starting point.
Half of the bottom one is 3.
Yeah.
So 3 squared
Good.
plus b squared
Good.
equals 12 squared.
Fantastic, absolutely perfect start from the righties. Centres, centre front,
Front and centre.
front and centre.
9 squared. Oh, sorry, 9.
9,
Plus b squared.
yeah,
B squared equals
squared
144.
that's right. We won't highlight that on the audio.
Oh, thanks.
And next step, fronties, front and centres.
Minus 9 from the left, minus 9 from the right.
Yeah.
And you end up with 135. Or b squared equals 135. And then
Yeah.
square root both of them.
And we square root both of them to give me b equals
11.6.
11.6. So that height is 11.6, which then allows me to go on and work out the area of a triangle. Amazing stuff, isn't it? Okay. So even when there isn't a right angle triangle, you can actually see right angle triangles in shapes by cutting them in half. And it doesn't have to be something like this. What other shapes could we create triangles from?
Oh, rhombus.
Rhombus. So if I drop a line down there, I can calculate the vertical height. And that's the sort of thing we'll be doing next week. So you can see right angle triangles everywhere, which is why Pythagoras is such an important theorem. When you see these guys on building sites with the old, laser pointery things, and they're calculating the height to the top and the bottom, they can calculate, they're using Pythagoras to calculate accurately the height of the wall and whether the wall is perpendicular to the ground or not. Yeah? So it's all through this guy and this kind of discovery. So what I'm going to give to you is a worksheet with 3 sections. So measures. Ooh. So I teach you measures with Pythagoras because we're now starting to use measures. You're going to come across measures next week when we start talking about area and volume and stuff like that. So this is an hour and a half bit of the lesson where we're going to cover The range of measures that we use, we're going to look at estimating measures. Now, I know it sounds stupid, but you will, or probably will, get a question on estimation of measures and understand and using these compound measures. For those of you who weren't here at the start of the lesson, what's a compound measure? Example of one?
Miles per hour.
Yeah. Miles per hour, litres per second on a flow rate, kilowatts per hour, all that sort of stuff are measures, compound measures. So that's what we're going to do for the next hour and a half or so. Some people get it straight away, others kind of struggle a little bit with it. There's no reason why not, why you should. So to get you into the mood of measures, I've got two starters for you. Okay, I'd like you to tell me what Joe and Anne get dished out on a ratio, and I'd like you to tell me how long it's going to take me to do 195 miles at 60 miles an hour. And I'd like it in hours and minutes, the answer. So I want the answer in hours and minutes. Okay then, on the first one for our starter, what's a good starting point then?
J and A.
Sorry?
J.
Oh yes, J and A. Let's get there. Let's do what I've been showing you since week 2 or 3. J and A.
And then 4 and 1.
In the ratio of 4 to 1.
And the total is, no, it's 5 parts.
5 parts, because we're talking about a total.
And 100.
Yep, so we've got.
then divide 100 by 5.
So because the 100 was relating to a total,
1 part,
so 1 part is worth.
20. So 4 parts is 80.
So 4 parts is 80, because we're multiplying each side by 20. And 1 part is 20.
Sorry, she's really happy. I hate ratios and I did it all by myself.
And did you lay it out like that?
Yeah.
And you're really happy? And Nikita, you're not particularly happy in the past with ratios, were you?
No.
But now you're nailing them. Because this is the format to do them in, yeah? So, exactly as you said, J and A, 4 to 1. The 100 is a total, so it went over that side. And then 5 parts in total goes into our total of 100, giving us 20 per part. We go back to our little J and A, and we multiply each side by 20.
I never used to remember the bit at that side. That's why I could never do it.
Ah, sorted. Okay, lefties. Who'd like to have a go at this one? It's all gone quiet over there. It's all gone quiet.
195 divided by 60.
Good. 195 divided by 60.
3.25.
3.25.
22 over a quarter, so a quarter of 60 is 15. So it's 3 hours.
3 hours, 15 minutes. Perfect. 15. Okay. So what I'd like you to do, because we're talking about time, it's quite an important thing throughout the paper. So I want you to tell me, it's not a decimal, what they are as decimals and what each of those are in hours and minutes. Shouldn't take a minute or two. So let's go through them. For the top ones, 30 minutes, what's that as a decimal?
No, wait,
0.5 of an hour. 15 minutes,
0.25.
4 hours, 45 minutes.
4.75.
Good. Other way around. 2.5 hours, 2 hours, 30 minutes. 3.25, 3 hours, 15 minutes. And 1.75.
1 hour, 45 minutes.
Good. Okay? It's because you recognise those fractions. They might not be as cute as that on the day. One of your homeworks, remember the lad, it was a scatter graph question. I don't know how I remember all these things. And he said, the track at 4 minutes, how long did it last? Not 4 minutes, but he gave 4 marks for it. And you had your scatter graph, and there was a little cross, and that was 4 minutes, and you went down, and it was 5, and it was 2 graduations. So it was like 5.2 or something. And everyone wrote 5 minutes, 20 seconds. It's 5.2 minutes. That's 5 minutes, 12 seconds. I can't remember if that's the exact number, but that's how they caught you out on it. And they will try and catch you out on time. Okay? So normally, when you get scales in measures, if you're lucky, they're nice groups of 10. So if I said this is 0 and this is 1, the arrow is pointing at 0.7. Yeah? Sometimes it might not be nice 10s. It might be divided into 5. So the arrow is pointing at 0.4. So whatever your scale is, you're working out what it is. So if it was time-wise, so if we say that's 0 minutes, 1 minute, 2 minutes, 3 minutes, how long did it take John to get to that point? What is that point in minutes?
1 minute 60.
1 minute, 1.6. So 1.6 minutes. 0.6 of a minute is how many seconds?
Right, let me say the question again.
This is an example of how they can change the scale for something like time. So you're quite happy at reading the scale that arrow is pointing at the number 1.6. If that was 1.6 minutes and I said what is that in seconds, 1 minute is 60 seconds. Everyone happy with that?
Yeah.
So what's 0.6 of a minute?
36 seconds.
Good, because 0.1 of a minute is 6 seconds, so that's 36 seconds. So that's 96 seconds is how long that music track lasts for or whatever. So you've got to be aware that sometimes in an exams, and it's not just measuring distances or weights, you're going to get these strange scales. Yes, you can read the scale, but you then need to convert from decimals into something like time. Okay? The diagram on the scale on the bottom is meant to show you that they can divide it into 4s. So if this is 0 and this is 1, each one of these is 0.25, a quarter. Good. And then this one I've divided into 3s. So 0, 1, 2 might be a scale. So they're all 0.33. Even worse, if that's 6. Sorry, not 6. That's 1. And you've got 6 divisions there. Yeah, it becomes nasty. You can spot that's the middle one, so you could put 0.5 on that, and then it's 0.5 divided by 3 tells you what each of the other 2 are. So you're not going to get anything that tricky, but they might give you something like that where it's divided into 3s or 6s. So scales on things is a very important thing. So pay attention to scales, especially when it involves time. Okay? So here's an example. They might say, read the scale for this weight. So what's that arrow pointing at?
240.
240 grams, perfect. Because we've got 100 between there and there. There are 5 divisions, so each division is 20 grams. I'm not going to teach you to suck eggs. Right, let's talk about metric units then, the main thrust of what we're going to do now. What's a metric unit? Anybody give me examples? What is it?
Thousands.
Sorry? Multiples of 10, yeah, tens, hundreds and thousands, yeah, I like that. So what examples of metric units do we know, do we use? Centimetres, kilometres, grams, litres, millilitres, centilitres, milligrams, yeah. Metric units introduced in Europe probably around the time of Napoleon, because a lot of these standards are actually held in Paris somewhere. The weight one is, it's a little kilogram weight in Paris that they polish every night. Okay, they're based on the decimal numbering system. So everything's in multiples of tens, hundreds and thousands, which makes lots of conversions really easy for us. You're either going to multiply or divide by a 10, 100 and 1,000. In order for that to make sense, you need to have a conceptual idea of what a millimetre is, what a centimetre is, what a metre is, what a kilometre is. Because if you do the wrong thing and you divide when you should be multiplying, it should stick out like a sore thumb. Even if you're multiplying or dividing by 10. If you use the wrong conversion, it will stick out because it won't make sense to you if you understand what the lengths are. So the idea of converting with these units is keep an idea of what they are and then ask yourself, does that conversion make sense? Because one will make sense and the other will be off the chart every time. Especially when you're multiplying and dividing by 1,000. It's like, is 1 kilogram 0.0001 of a milligram, or is it 1,000 milligrams? Well, if a milligram is a tiny grain of sugar, 0.0001 of a milligram is going to be almost nothing. So how can 1 kilogram equal that? So when we come on to conversions, think about what the units are and what you're converting them into, and there'll be a right answer and there'll be a stupidly wrong answer most of the time. Okay? So let's look at length then. What is length? How do we define length? It's a measure of distance. Okay? And we use rulers and all sorts of things to measure length, okay? And you should be able to read length. And they actually won't have to test you on measuring length, because they'll combine some of your measures with some of the construction that you did last week. So when it asks you to draw a 3, 4, 5 triangle, they know that you're measuring things correctly on your ruler to create that 3, 4, 5. So some of the ways they test you on measures, they won't just ask you straight out to read something off a scale. They know that you've done it correctly when you construct your 3, 4, 5 triangle. Okay? So let's talk about lengths and estimating lengths and what we use to measure lengths. Okay? So if I said to you the width of a coin, what would we measure that in metrically? Millimetres, yeah? Very thin. Do we know what we measure millimetres with? Ruler, you got a ruler if it was a few millimetres, yeah? Micrometers, screw gauges, all sorts of specialist tools. Length of a book? Centimetres, yeah? Use centimetres. Length of a swimming pool?
Meters.
And distance here to Aberdeen, kilometres. So they are our metric length measurements. Our millimetres, centimetres, metres, kilometres. They could ask you for things like what sort of units you would use for the height of Blackpool Tower. What would you use, height of Blackpool Tower? Metres, thickness of a paperback book. Centimetres, if it was War and Peace. If it was one of those Mills and Boon, millimetres. Length of a football pitch? Metres. Thickness of a matchstick? Millimetres. And then distance from Leeds to Manchester? Kilometres. I know it sounds stupid, but they might put these up with the units over there and you have to join them together with those lines kind of thing. So they want to get you to accept that you need to recognise what units go along with what distances. The key to metric units are what we call the prefixes. Everyone happy with what a prefix is? Yeah? Comes on the front of a word. So when you see kilo, centi and milli, they mean something. So kilo means what? 1,000. Greek for 1,000. Centi? Yeah, centurion, century. Milli? Millipede, millimetre. It's
10.
Yeah, it's thousands. In theory, that's hundredths, and these are thousandths. Yeah. So these prefixes tell us our conversion, because when you apply them to meters or centimeters, I don't know, you have a base unit. Your base unit for length is the meter. So everything is referenced to the meter. A kilometre is 1,000 metres. So 1,000 metres makes 1 kilometre. A centimetre is 100th of a metre. A millimetre is 1,000th of a metre. Okay? So how big's a metre? If you were... you watched it. Is that on the newspaper this week?
No, I don't know. It's my mum's.
From the end of your finger to the tip of your nose. That was this week. I saw that in a newspaper.
It can't be for everyone.
So it's
but
basically
about.
from the end of your finger to the tip of your nose when you look away.
Yeah.
And I said, but you get different people at different lengths, and some people got long noses and little noses. Anyway, so roughly it's that kind of distance. It's like there. And you're thinking, why do I have to know that? Well, every other exam paper, you'll get something like this. I don't know if Ramesh has seen this one. Having just walked in, I'll talk to it. And they'll put a man next to a lighthouse or a tower, and they will say, estimate how high that tower is. So they're expecting you to know how tall a human is. How tall is an average man?
6 foot.
6 foot? Average man is 6 foot now. It used to be 5 foot, about 8 a few years ago. Close to here, I'm average. 6 foot is average now. Okay, let's not argue about that. So 6 foot. So what's that in metres? Because they're going to ask you for the answer to this.
1.6.
No.
I'm 1.6. It's
No,
about
I'm
1.8.
1.73 metres.
Or 1.9 then.
Yeah, it's about 2. Call it 2 for cash. Call it 2 metres for cash. So a 6 footer is roughly 2 metres. Yeah? Does that sound about right? Yeah, I'm 173. It was on my ID card for decades. Right? So they would say to you, how high is that tower? And that's all they'll say, and they want it in metres. So if you say he's 2 metres, then you do that and you say it's 6 metres high. And you do get questions, every other paper like that. that will ask you to estimate the height of something based on the height of the little man standing next to it.
So what is the average, sorry? 1 point...
Well, we're calling it 2 for cash because apparently it's your average height is 6 foot now. I'm a bit shocked because in my day it was 5'8", and I've always been saying, oh, I'm about average.
If you got that question though, is there not a baseline?
Sorry?
If you got that a question like
Yeah.
that, is there not a baseline?
Well,
They
the
probably
baseline
accept
is
between-
the height of the average man is 2 foot, and you're just estimating it.
What
Doesn't
if-
matter if it's 1.9 metres or 1.8. I reckon it's about 1.8 metres,
Yeah.
which
What
is
if you've
about
got
5'9".
Okay, your man equals 1 metre. Very
Then you've
small
got to-
man.
yes.
Do a key at the side.
You wouldn't get away with it because it says in the question it will be worded based on the average height of a man. So 1 metre isn't the average height, so they expect you to know that's roughly I'd go for 1.8 metres. If you want to go for 2, fantastic.
If
And then
you
just
wrote-
do something like that and estimate it.
If you wrote down though, average 1 point, whatever you're basing it on,
Yeah.
surely you would get it right.
But if your average is way out, if you say the average height of a man is a metre, it shows that,
Thickness.
yeah, you're not actually catching what a metre is. So you have to have a concept that your average size bloke is about 1.8 metres or 2. Round it up, yeah? So on these factors, they'll expect you to switch between the various sizes here, okay? So we've already done this. There's 2 or 3 ways of doing it. So I'll just show you each way. You can decide which way you want to do it. Then I'll give you some questions to have a go at and just to have a go in the way that suits you best. The first way is to treat them, a conversion, as a ratio, now that we're all dead hot on ratios. So I know that 1 metre is 100 centimetres is 1,000 millimetres. Everyone happy with that? So if I give you any one of those values, I can switch to the others really quick. So if I say something's 5 metres long, if we deal with it as a ratio, we know exactly what we're doing now, don't we? Because I'm multiplying that by 5, I have to do the same over there. Does that make sense? Yeah? So that's one way of doing it, treating it like ratios. You can't go all the way up. I haven't joined kilometres here specifically because the ratio then swaps. Because it isn't one of these to 1,000 of those, it's the other way round. So when you deal with kilometres, you need to switch your ratio to that, because that's what it means. 1 kilometre is 1,000 metres, and then deal with it. So ratios is the first method that you can use to switch between centimetres, millimetres, metres, kilometres. But just be aware, if you go past metres up to kilometres, it's a standalone thing. These 3 all link together. The other way that I taught last year was this. And some people used to say, oh, I'm going to write that down as soon as I get into the Unit 3 exam. And that is, you write them down in order. That you know a kilometre is the longest, metres, centimetres and millimetres. And when you go from a big unit to a small unit, in other words 1 kilometre, you multiply by whatever the prefix is. So 1 kilometre is 1,000 metres. So when you go from left to right, you multiply. And when you go from right to left, you divide. So that's method number 2 I'm offering you. Yeah? Or whatever method you might already have. If you've got a method that works for you, don't try these. So this is method 2. So method 1 is a ratio. Method 2 is if it's big to little, you multiply, little to big, you divide. I can see a lot of people scribbling, so I'll leave it up there for a second. Take a break in a minute, as soon as we've done lengths. Is it me or is it warm in here? Melty. Okay, everyone happy with that? These are all on my course and lesson slides and everything. And then the third way is you just remembering that 1 metre is 100 centimetres, 1 kilometre is 1,000 metres, and applying the correction yourself, dividing or multiplying by 10, 100 and 1,000, whichever way you want to do it. Okay? So just remembering what the conversions are and applying it in your own way. So, have a go at converting those 3. So let's go through them then. So 14 kilometres. Anybody use a particular method? Anyone use the ratio method, the conversion? Decimal point method. So what did you do with your decimal point?
Well, I moved it 2 places to the right because it's that.
So what did you get as an answer?
14,000.
So So you moved it 3 places to the right. Yeah, so you multiplied it by 1,000 kilo. So 14, 1, 2 would be 1,400. 14,000 is 3 decimal places. So you multiplied it by 1,000. Everybody multiply by 1,000. So we know 14 kilometres in our heads is a long distance, and I know a metre is this, so I'm expecting it to be quite a lot of these. If I'd have divided it and ended up with 0.014 of a metre, it wouldn't have made sense. You see what I'm saying? So think about the conversion. Don't just get into maths and just do the maths and think you've got the right answer. So 23.5 centimetres. What do we do there?
I've divided it by 100.
So this tells us it's 100, so 10, 100.
0.235.
Good. Yeah. Because I know a metre's up here, and if I look at my ruler, I see 23 centimetres is something like that. I'm not expecting it to be 2,350 metres, because that then doesn't make sense, if you catch my drift. 45 millimetres. What have we got for that table at the back?
0.0045.
Good. Milli tells us it's something to do with 1,000. I'm either going to divide or multiply. If I multiplied that by 1,000, it would be 45,000. Doesn't make sense, does it? Because a metre's that. 45.
I'm missing a 0. I've only got 1 0 after the decimal.
Oh right, 1, 2. Yeah, you're right. 0.
Yeah.
Not 0, 0. Sorry. 0.045. Yeah.
Would that not be 4 centimetres or?
No, because milli's 1,000 and we're converting it into metres, so you need to do something with 1,000. So you need to divide this by 1,000. So
yeah, if that was a metre, so say the first 0 was a 1, and you had like 1.04, would that not be like 1 metre and 4 centimetres?
Sorry, on this one, if we had 1.04 metres...
To two decimal places, would that not be like between 0 and 10? Do you know what I mean?
No, to be 1 metre and 4 millimetres.
Like if you had, where you've got the 1.4 now, that would be 1.4.
That's
1 metre 4 centimetres, wouldn't it?
Yeah, because there's 100 centimetres in.
Yeah.
Yeah, but I've got 45. I haven't got 4 millimetres, I've got 45 millimetres.
Yeah, that's what I mean, it's millimetres, not centimetres.
Yeah, but that's 4 centimetres, which is 45 millimetres. Because there's 10 millimetres in a centimetre.
Yeah, I get where I put the 0.
Yeah, so if it was 4 millimetres, you'd be right, you'd have the
yeah.
2 leading zeros. Yeah? Okay, just place value, that's
You
it.
could go the other way to check it. Do you know, like once you've got your result,
Then
times
then
by,
times it by
go the other
1,000
way.
and do the other thing. Don't worry about measuring stuff and rulers. They're not going to get you to do this because you're going to do it in a practical way when you do construction. I'm going to push on with these measures, okay? So, weight. What is weight? What's the definition of weight? How heavy something is. Yeah. A measure of the mass of an object, okay? We're now going to look at metric weights. So, really light weights.
Pound.
Grams.
Oh no,
Kilograms.
grams. Sorry.
Cubes, grams, really light weights.
Milligrams.
Milligrams, grams, weight of a human, kilograms,
Ton. Oh, no.
ton,
Is it ton?
the metric ton, T-O-N-N-E. It's probably the only thing that doesn't fit our little prefix rule. Okay? So you need to have an idea of what weighs what. So if I was going to weigh a car, I'd measure it in
Metric ton.
metric tons, weight of a bag of sugar,
Grams. Oh,
kilogram. It's the de facto standard for a kilogram. Everyone's done functional skills. They will say what weighs a kilogram, and they'll ask you to picture the bag of sugar because that is exactly a kilogram. Weight of an adult,
kilogram.
weight of a sugar lump,
Gram.
weight of an amount of butter in a cake, grams, always see it on the recipes. Weight of a bag of sweets,
Grams.
and weight of a feather, milligrams. Good. So can you recognise them? Quite nice and neat. When we talk about weights, our standard unit is the gram, and we either go up or down by 1,000. So, if you've converted it right, it will stick out like the proverbial dog's doodahs. Because if you get it wrong, it will stick out so much that it's wrong that it won't make sense. So you've got your standard of a gram, so a kilogram you're multiplying by 1,000, a milligram you're dividing by 1,000. And the same for a ton. Everything in weight is 1,000, because there's 1,000 kilograms in a metric ton. So it's 1,000, 1,000, 1,000. So our three methods of conversion. You can do it by ratios if you want to. If you're given one, you can work out the other. Again, you have to break them up so they don't all appear in a line. You can use our wonderful line method, where if you write them out, tons, kilograms, grams and milligrams, it works out really neatly this time, because when I go from big to small and I'm multiplying, I'm only ever multiplying by 1,000. When I come back the way, again, I'm only ever dividing by 1,000. Okay. So that's the scale going from big to small, small to big. I can see people scribbling. I'll leave it up there for a second. That seems to be a popular one. Okay, scribble's done. And then there's the standard, just remembering there's 1,000 milligrams in a gram, 1,000 grams in a kilogram, 1,000 kilograms in a ton, and you just apply the correct factor. So there you go. There's 5 or 6 to have a go at. 2, 4, 6, 6 to go. So from the top then, righties. What have you got for the first one?
1,200.
Good. Got 1,200 kilograms. If I'd have divided by 1,000, it would have been 0.0012 of a kilogram. But I'm talking 1.2 tons, size of an elephant. 0.012 of a kilogram, kind of a few grains of sugar. So one makes sense, the other doesn't quite make sense. 3.1 tons, centre backs. 3,100. 0.9 of a ton, front and centres.
900.
900 kilograms. 2,000 grams, lefties. 2 kilograms, good. Righties. 2,500 grams. 2.5 kilograms. Centre backs. 0.25 per kilogram. Good. No problems there with converting weights. Now let's look at our last of our metric units, capacity. What is capacity?
Milliliters.
Millilitres is a unit, good.
Volumes.
Water, volume, all good things. Yeah, capacity is how much something holds, basically. The amount of fluid, so water, a container can hold. Measured in millilitres, use experiments, water and all sorts. So let's have a look at the litre units then. This is probably the easiest of the lot. Got a tiny amount of
Nail varnish.
perfume, nail varnish, whatever it is, measured in millilitres, tiny amount. Sometimes see it on Coke cans, centilitres, filling up at the station, litres. So notice this time we don't have kilolitres. You can if you want, but there isn't a standard unit. So the beauty about litres and capacity are that they're all smaller than our standard unit, the litre. So if I was going to measure a cup of water, we'd measure it in millilitres or centilitres, either. A reservoir,
Liters.
yeah, something massive is still just litres. A bath,
Liters.
bucket of water, car petrol tank, and a teaspoon of water. Millilitres. A litre, that's half a litre. So 2 bottles of this is a litre of water. We had somebody with a litre bottle this morning. Nobody's got a litre. So that's half a litre. Okay? So have an idea of capacity and how much things hold, just in case they ask you for an estimate of how much a cup of water is, or a bucket of water. So like I say, the standard unit is the litre. There's nothing bigger than a litre, no kilolitres. Yeah? So all you need to remember are the centi and the millis. So a centi is 100 of these, 1,000 of these is a litre. Okay? So using our ratios, it makes our ratios dead easy. 1 of these is 100 of these, is 1,000 of these. Notice when we did lengths and also with capacity, if you go from this one to this one, the factor is 1 to 10. Yeah, because I've got 100 of these and 1,000 of those. You can actually link these together. So when we did length, there are 10 millimetres in 1 centimetre. That's where it comes from. So it's the same here. Because you haven't got a ruler in the exam, it's not as easy to visualise that. If you've got a ruler in the exam, you know that straight away. Okay. So our conversion, quite straightforward. Highest is the litre. Go from high to low, you multiply. From low to high, you divide. Some people like scribbling these down in the exam as the way to convert things. It's up to you. Generally, you'll get one conversion question in the exam, and maybe not between these. See a few people scribbling. I'll just give you a couple of more seconds. Okay. Or there's the third version, which is just remembering there's 1,000, 100, and 10 of these into 1 centilitre. So, 2 things for you to convert then. Convert the following into both centilitres and millilitres, 1.2 litres and 0.6 litres, and then convert the following from millilitres into litres. There's going to be an obvious answer and a less obvious answer. So 1.2 litres, how many centilitres is that?
120.
Yeah, multiply it by 100, gives us 120. How many millilitres?
1,200.
1,200, good. 0.6 of a litre in centilitres?
60.
60. And millilitres?
600.
600. Okay, so in both instances we're multiplying by the prefix. Centi 100, the milli 1,000. One at the bottom then, millilitres back into litres. So 1,400 millilitres, 1.4 litres, and then 500 millilitres, 0.5 of a litre.
This might be a bad question. Would they not allow you to take 2 bottles into an exam?
Right.
Seriously, I just use that. That's got
Yeah.
500
No, seriously,
millilitres,
for
that's
exams,
500.
you can take water only into the exam and you have to remove the label.
They've got 2 different ones. I just use them to work them out then.
Right.
That's got millilitres and that's got centilitres.
Okay. But realistically, in the exam, you can take a bottle of water in, but they'll force you to remove the label before you go in. Just to stop you writing notes on labels and all sorts of tricky things. I don't know. It's ridiculous. So yes, you can take your bottle in, but you'd have to remove it. So you haven't. It's not like taking a ruler into the exam and you know your centimetres, your millimetres, and all the rest of it. You're not going to get that unless it's printed on the plastic of the bottle. So if you can find a brand of bottle that actually has the conversion in on the plastic, that's the only way to do it. And I don't think they do. I think they all put them on the paper labels. Okay. So let's have a look at this then. In summary, for our metric units, our metric conversions, we have 3 basic units: metres, grams and litres. And we use prefixes: kilo for 1,000, centi for 100th, and a milli for 1,000th of those units. So if you visualise it that way, that I've got my metres, my grams, my litres, and I'm either multiplying by 1,000 or dividing by 100 or 1,000, your metric conversions should be quite straightforward. Okay.
Are they not allowed to ask imperial?
Guess what we're coming on to next? Oh, it's as if I've teed you up for this. I'll give you the worksheet to take home. You don't have to do it. Any other things?
Fluid ounces.
Fluid ounces. So we've got things like, somewhere on here, yards. Anybody mention yards? We've mentioned miles. Fluid ounces, stones. Somebody mentioned gallons. Yeah? Pints. Pints and gallons, anybody know the relationship? 8.
Right.
Yeah? I used to go out for a night out, try and get the old 2G. Never did it myself. It's more of a bottle of Beck's man myself, right? Anyway, so they're the kind of units you've got. Bad news for you. You have to remember 4. There are 4 conversions that you're expected to know for the exam. If you get a question to convert miles to kilometres or vice versa, litres to gallons, pounds to kilograms, inches to centimetres, they're not going to give you the conversion factor. You're expected to know it. Anything else involving pounds, ounces, yards, anything well, not feet in inches, you should know that's 12 inches in a foot. Okay? But any conversions of those, they will not give you the conversion factor for it. You're expected to know that there are 5 miles to every 8 kilometres, 4.5 litres to a gallon, 2.2 pounds to a kilogram, and 1 inch to 2.5 centimetres. And this little excerpt here came straight out of the GCSE guidebook. The good news for you is converting between those is a doddle, because we've done it all before as ratios. Yeah? If you look at all of those conversions, they are essentially a ratio. If I've got miles to kilometres and I say, I travelled 25 miles to get here today, what is it in kilometres? Where do I put my 25?
Under the M.
Under the 5, because I travelled 25 miles. I've multiplied it by 5. Do the same that side. 40 clicks. Yeah? The same for anything. If I've got 3 gallons of oil, how many litres do I need? If I go to the garage, multiply it by 3, and I get 13.5 litres of oil that I need. So these conversions, if you can remember this, then just turn into nice, straightforward ratios. If I've got, kilograms to pounds, and how much does an average man weigh? We know he's 2 metres tall, 6 foot tall. How much does that guy weigh? In kilos, roughly.
80.
80? He's probably a bit skinny at 80 at 6 foot tall, but yeah.
So I always think of it as stone. So I know I'm 10 stone. Whatever.
Right.
But I wouldn't know what that would be in kilograms.
Okay, well this is kind of what tells you if you knew what it was in pounds.
60. It's about 60.
60 kilos. Does anybody know their weight in kilos?
Yeah.
Yeah.
I do, but I'm not telling you.
I did it before to work out my BMI.
So not many people know their weights in kilos.
I do.
62.
Yeah, an average man would be about 80 to 90 kilos. Yeah, so that's a pretty good benchmark for your average bloke. Okay, so next time you weigh yourselves, have a look at the kilos, because it's the kilos that count. Because what do you calculate with kilos that's important to your health?
Kilocalories.
BMI.
BMI. What's the BMI?
Body mass index.
Yeah, which is what?
Oh.
Anyone remember what it is?
Height.
24, 25.
Height divided by your...
Yeah, I did it this morning.
Body
Is it your height squared divided by your weight or something? It's something like that. Or it's the other way around, isn't it? Your weight divided by your height squared. I think that's it. So for your body mass index, that weight is in kilos. So if you're going to work out your BMI, you need your height in metres and your weight in kilos. Okay. So pounds to kilograms, it could be relevant, especially if you're in sport or whatever, and people are coming in and going, yeah, I'm 160 pounds. Well, what's that in pounds and kilos and whatever? Okay, so you need to remember these conversions. So let's have a go at a few then. I'm being kind to you. In the exam, you won't have that there. But they could quite easily say, convert 25 miles into kilometres, convert 8.5 gallons into litres, convert 3 pounds to grams, and convert 105. What is 105 centimetres in inches? Easy peasy one. Centre rights. Talk me through the first one then. Convert 25 miles to kilometres.
I got 40.
Okay, what's a good starting point if we're going to do these conversions?
M, then KN.
Yeah, we've got M and KM. So we've got miles to kilometres, and what do I know?
5.
To 8.
25.
So the 25 goes under miles. So that relates to this, and we've multiplied it by, as Nikita says, 5. Have to do the same on the other side. That gives us 40 kilometres. So 25 miles is 40 clicks. See how it works? It's all ratios. So if you get your head around ratios and lay them out this way, you'll never get another ratio wrong. Right, let's do gallons and litres then. Centre fronts.
Shall I go?
Yeah.
So a litre and a gallon, 2.
So I've got a litre and a gallon, and I've got a conversion of
litres, 4.5.
4.5 to 1 gallon.
So I times 1 gallon by 8.5.
So we've multiplied it by 8.5 to end up with our 8.5 gallons.
I did the same to the other side. I ended up with 36.45.
36.45 litres. Happy with that?
Oh yeah, it could be my
I got
My bad.
38.25.
38.25. Okay. I'll bow to your knowledge. I'm not
Yeah.
going to do that one in my head. 38.25. 38.25. Majority wins.
Yep.
Okay. Good. The next one, not so easy. Lefties. Talk me through it, lefties. Oh, still working on it. Lots of scribbling, rubbing out, all sorts going on here. Anybody like to talk me through it? Centre backs, do you want to help them out?
You've
Not
got
got a
to-
clue.
I used 1,000 instead of 1. So I did pounds, 2 point, you know, my 2 columns.
So I've got my pounds and I've got
2
my...
kilos.
Yeah, do the kilograms first. So
Yeah.
what have I got? 2.2 pounds to 1 kilo.
Yeah.
We know that because we've been given it. What do we know?
We've got 3 pounds.
So what have I done to get from 2.2 to 3? How do I work that out?
Have you times it by 1.36?
1 point, yeah. You divide 3 by 2.2 and it tells you that you've multiplied it by 1.36. That's how you get the conversion factor. You divide this by this and it tells you what you've done to get it. So if I multiply that by 1.36, it tells me I've got 1.36 kilograms. It wants the answer in,
Grams, so times it by 1,000.
so multiply it by 1,000, 1,360 grams.
Sorry, I don't get it. You don't know.
Isn't it divided by 1,000?
The 2.2.
Oh no, hang on, no, you're going
Do
down.
that.
It's 2.2 to 1. So to get from 2.2 to 3,
Yeah.
how do we work out what number we multiply it by?
I don't know.
Well, it's like multiplication. You divide 3 by 2.2 and it tells you what you've multiplied them
So
by.
do I say 2.2 into 3 or 3 is into 2.2?
So if I've got 3 and 6 and I go from 3 to 6, what have I multiplied it by?
True.
Because you can see that straight away.
Yeah.
What have you done mathematically? I've divided 6 by 3 to get to 2.
Times it by 1,000.
Does that make sense? So, to get from 2.2 to 3, how do I get whatever it is I'm multiplying it by? I divide the 3 by 2.2 and it tells me it's 1.36. So I multiply that by 1.36. You've been doing these for the last 6-9 months off the top of your heads because they've been nice numbers. As soon as we introduce a nasty number, it's kind of thrown a few of you away. The technique you're using to get from, let's say, 3 down to 12, what have I multiplied by 3 to get 12? 4. Because 12 divided by 3 gives me that 4. Yeah? So it's the same technique. What do I multiply 2.2 by to get that? I divide 2.2 into 3 and it tells me it's 1.36. Yeah? So if you get nasty numbers, that's how you get the nasty number. Does that make sense?
Yeah.
Amanda, you're still with me?
Yeah, I'm just working out which way to put the 3s and the 2s. It's alright, I'll get them.
Okay. Let's have a look at the last one then. 105 centimetres into inches. Lefties, righties, anybody? Want to have a go at this one?
Did centimetres and inches.
So we've got inches and centimetres, inch and centimetres, and I've got a conversion of 1 to 2.5.
Did 105 divided by 2.5.
Good, so 105 divided by 2.5 gives me my conversion,
42.
which is 42.
So times 1 by 42, 42 inches.
Good, so you end up with 42 inches as the answer to that one. Okay. So if you've got these tricky numbers in your conversion, 2.5 to 105, you divide 105 by 2.5 and it tells you what you've multiplied it by. Yeah. But because most of this course we've been using easy numbers and we've just introduced nasty numbers today, it's kind of thrown a few
We
of
didn't
you.
have a calculator when we were doing those, did
Exactly.
we? So we had nice numbers.
Yeah, so they're always nice numbers. I'm getting nasty on you now. Okay. If they ask you to do any of the other imperial conversions, they will have to give you what the imperial conversion is. So the only ones you need to know is 1 inch, 2.5 centimetres, 8 kilometres is 5 miles, 1 kilogram is 2.2 pounds. Those 4 are the 4 you have to know. If they give you anything else to convert things with, either imperial to imperial or imperial to other categories, they have to give you that conversion factor. Yeah? So don't worry about remembering all these tables and all the conversion factors. Remember the 4 that you've got. Okay. So Jessica is 5 feet 4 inches tall. What's her height in meters? Right, let's do this then. What's the first thing I'm going to have to do?
Work out how many inches there are.
Brilliant. So I've got 5 feet 4. So how many inches is that?
64.
64, because 5 12s is 60 plus the 4 is 64 inches. Then tell me what I know. What do I know? Inches to
centimetres.
centimetres. That's the conversion factor I know.
2.5
So it's 1 inch, 2.5 centimetres.
times 64.
I've times by 64 to get my inches. So what do I have to do to my centimetres?
Times 64.
64 times 2.5.
160.
160. That's in centimetres. What's the answer in metres?
Times 100.
Times 100. Not times 100. That would be massive, wouldn't it? That's what I mean about the wrong answer.
Times 10. No.
Divided by 100.
It's in centimetres, so I'm going to divide by 100.
Because
Yeah.
you want it in metres.
Sorry, I want it in metres, so I'm dividing by 100.
Okay.
If I multiply by 100, it becomes 16,000 metres. See what we mean about the answer making sense? So you divide it by 100, and it gives you 1.6 metres, which is about right.
Where did you even get the 64 from?
I don't know.
5 feet 4. How many
I haven't
inches?
got a conversion to say how many inches is in a
You're
foot.
just supposed to know.
I
This
didn't
is
know
the-
that.
Yeah. As in, this is just a thing.
You need to know there's 12 inches in a foot.
I didn't know.
Sorry, did I not say that earlier? On these, some of these really basic ones, 12 inches in a feet, that's assumed knowledge.
You just go off your heights if you're like 5'10" or 5'11".
Yeah, yeah.
Then when you go to
The 12, you know, you're a
up
6
it,
footer.
Yeah.
But do people not know there's 12 inches in a foot?
I know.
Right. That's another one you'll need to remember. I'm going to add that. That's assumed knowledge. I was under the impression everybody knew there were 12 inches in a foot. Because everyone talks in feet and inches. When we said, oh, how tall are you? In metres, everyone, oh, I don't know that. Oh, I'm 5'7". You think, okay, so you understand about height. 12 inches in a foot is why you're 5'6" or 5'4". If you convert it into inches, it becomes 64 inches. Yeah? 5 lots of 12 is 60 plus the 4, 64 inches. So I'll add that then. I'm going to add that to the lesson. So I'm not going to assume knowledge that everybody knows there's 12 inches to a foot. We'll add it to the list. Are you happy with the rest though?
Yeah.
Yeah? Haley, you
I'm
all right with that?
to go down.
Once we got the 64.
And then divide by 100 is because you're converting the centimetres to metres.
Yeah, centimetres to metres, you divide by 100. Start lesson, we say what a compound measure is. What's a compound measure? When you have more than one unit. So what was my example? Good. So when we talk about miles per hour, I'm saying, for example, 60 miles in 1 hour. It's a ratio. Give me other examples of things that we talked about, compound measures. You gave me some yesterday that were really good. Beats per minute, BPM. You're all going in the medical profession. Beats per minute. So if I say, oh, I've got pulse rate of 54 beats per minute, it means my heart beats 54 times per minute. So this is beats and this is minutes. Okay? Another one, anything. Compound. Oxygen rate, number of breaths per minute, similar to beats per minute, yeah, 20 breaths per minute. All compound measures is combining two things. One of the most popular ones is miles per hour and distance and time, okay? So we're just going to spend 2 minutes on distance and time because it's tested specifically, okay? So, speed, distance, time. What do I use to calculate the speed, distance, time problems? My triangle. And what's at the top of my triangle on my speed, distance, time triangle? Sorry? Speed? Sure.
Yes, it's SDT.
Think about how do I calculate?
Will it be D at the top, distance, and then speed, then time?
The speed distance triangle has the d at the top, because your distance is equal to your speed times your time. So if I'm doing 30 miles an hour for 2 hours, my distance is 60 miles. So you need to remember this. And this is going to be crucial for the hardest thing you have to do on compound measures. And we're going to switch between units using this. This was my revelation earlier. Okay? Everyone happy with the speed, distance, time triangle? So if you don't know something, you cover it up and it tells you what to do with the two things that you do know. Yeah? Do those 3 questions for me to prove you can use the speed, distance, time triangle. I drive at 30 miles an hour for an hour 30 minutes. How far have I travelled? If I've travelled 90 miles in 2 hours 15 minutes, how fast was I driving? And then how long will it take me to travel 190 miles at 40 miles an hour? And I want the answer for that one in hours and minutes. Okay, we need to move on, otherwise we're not going to get this last bit done. We've got speed, distance, time triangle. So what does it give me in my triangle and what doesn't it give me? So if I drive 30 miles an hour, what's the 30 miles an hour? The speed. So 30 lives in there. And I drive for 1 hour 30 minutes, so what else is it giving me? So 1 hour 30 minutes, what do I...
90 minutes.
Not 90 minutes, it's 1.5 hours because we're doing miles per hour, not miles per minute. So it's 30 miles an hour at 1 hour, 1.5 hours. So to get my distance, I multiply 30 by 1.5 and I get 45 miles. The second one, speed, distance, time triangle every time. I travel 90 miles, so the 90 is my distance, in 2 hours 15 minutes. So 2 hours 15, 2.25 of an hour. So my speed is 90 divided by 2.25, which gives me 40 miles per hour as my speed. The third one, speed, distance, time triangle. Put in what you know. So I've got my triangle. I do 190 miles, so that's my distance, and my speed is 40 miles per hour. So to get my distance, I divide 190 by 40, and I get 4.75 hours. And to get it in hours and minutes, it's 4 hours and 45 minutes. So the speed, distance, time triangle, you put in what you know. The trick is the time. Decimal time. Decimal time. If you get decimal time out as an answer, can you convert it into hours and minutes? Yes, you can. Okay? Good. The hardest bit of all of what we're doing with measures and on compound measures is this. Now, last Wednesday night, I did this way, and it just blew everyone away. Tonight, or today, sorry, I'm going to delete it because it's irrelevant. I'm going to show you how to do this with Pete's new triangle method. Right? I love me triangles. Right. I draw my speed, distance, time triangle. What's on the top? Distance. What's down here? And what's this one? Good. So I'm going to convert 10 miles per hour into meters per second. So my speed is 10 miles per hour. So I want this to be in something in meters per second. That's my speed. I don't know what it is yet, so I'm going to leave that there. My distance. So what does 10 kilometers an hour tell me? It's not
60 miles.
So let me just rub this out. I've written miles, haven't I? It's kilometers. 10 kilometers an hour. So what does this tell me? How many kilometers are I doing per hour? 10. So my distance is 10 for every 1 hour I do. Does that make sense? That's what speed is, 10 kilometers per hour. So my speed, distance, time triangle with my original information is I do 10 kilometers per hour to give me 10 kilometers an hour. I don't want kilometers, I want meters. So how do I go from 10 kilometers into something that is in meters? So, how do I convert 10 kilometres into metres? What is it?
How many kilometres are in
Well, there's 1,000 metres in a kilometre, so you divide by 1,000.
Think about your answers. I've got 10 kilometres, which is a long distance. So to get it into metres, it's not going to be 0.001 of a metre.
No, 1,000 times.
So you're going to multiply it. So it's how many metres?
10,000.
10,000 metres. So I've got 10,000 metres in 1 hour. I don't want it per hour. I want it in seconds.
You're changing your hours.
Good. So I've got 1 hour. How many minutes is that? 16 minutes. How many seconds is that? 60 times 60, which is 3,600 seconds. So 1 hour is 3,600 seconds. So now, to get metres per second, I've got my metres, I've got my seconds. What do I need to do?
10,000 divided by 3,600.
Because this tells me what to do with them. I divide that by that. So when I do that, what do I get?
2.7.
2.7 metres per second. So I've converted kilometres an hour into metres per second using Pete's new fancy speed distance time triangle. Does that make sense? Yeah? Did you get that?
I got it. Yeah.
Right.
Yeah.
We started off with our original 10 kilometres an hour. It means every 10 kilometres I do 1 hour. I don't want kilometres, I want metres. So I convert my kilometres to metres by multiplying by 1,000. I don't want hours, I want seconds. So I convert my hours into seconds. I then do my calculation, metres per second, by dividing this by this, and it gives me 2.7 metres per second. Yeah? I think that's genius. We'll do another one. Okay? That's how I used to lay it out, and it just used to blow people away. Stick to the triangle. I'll do another one for you, just to show you how good this is. Right? Pete's triangle. What's at the top? What's on the bottom left? What's on the bottom right? So I'm starting out with a speed of 70 miles per hour. So what does that mean, distance and time-wise? I do 70 miles in how long? 1 hour. So let's do our conversions. I don't want miles. I don't want 70 miles. What do I want?
You want it per second.
Meters. No, I want meters. Let's just concentrate on one thing at a time. So I've got 70 miles. I want 1 meter. So what do I convert? Miles to kilometers is... So I've got 70 miles. I don't want 70 miles.
5 divided by 70.
No, the other way around. 70 divided by 5 gives me...
14.
Multiply this by 14, I get...
96, isn't it? Oh, 96 plus another 4. 16.
It's 100 and something, isn't it?
Yeah, I was adding it up in my head. In my twos.
112. So 70 miles is 112 kilometres. So it's 112 kilometres. I don't want kilometres. What do I want?
Meters.
I want metres. So I'm going from miles to metres. So what do I have to do with 112?
Times 1,000.
By 1,000, so it's 112 with 3 zeros after it. Brilliant. So 70 miles is 112,000 metres. That's the first bit done. Let's do the second bit. I don't want hours. What do I want?
Seconds.
So I've got hours. So what do I have to do to get to seconds? 60 times 60 gives me... Good. So I've now got the units I'm interested in. I've got my metres and I've got my seconds. Does that make sense? So now when I do... I've got 112,000 and I divide it by 3,600. What do I get?
I've got 31.1.
112,000 divided by 3,600.
It's 31.1. With a dot above the 1. Yeah.
Okay.
That's a lot of metres per second, but that's a lot of miles per hour, I suppose.
70 miles an hour is flying on the motorway, isn't it? Okay. And that's how it works. How you go from miles to kilometres to metres, how you go from hours to seconds. Meters divided by seconds gives you the unit you want. I'm going to finish today. You're going to do one of these for me, and you're going to do that one. Have a go at that one. I've got something at 20 kilometres an hour, and I want to convert it into meters per second. Sorry, 20 kilometres an hour into meters per second. Have a go at that, see if you can do it. But it works for any of these conversions, okay? Miles per hour, kilometres an hour to miles an hour, meters per second to kilometres an hour. Right, let's go through it then. So our original speed is 20 kilometres, so I do a distance of 20 in 1 hour. So that's kilometres. I don't want it in kilometres, what do I want it in? Meters. So to get meters, I multiply it by, so I end up with 20,000 meters. I don't want hours, what do I want?
Seconds.
I want seconds. So how do I get from hours to seconds?
60 times 60.
Which is,
3,600.
so my speed is 20,000 divided by 3,600, which is 5.5 meters per second. Doddle, isn't it? And that would be the hardest question on measures that they could give you, especially compound measures. Okay?